Hey directors, so this week we are talking about multiplication, and the first thing that I do, I set the timer 5 minutes and we do our number knockout. You can see that in the first week if you need to see that again. After the 5 minutes, we're done with our little warm up and then we move on to the cover. And so in terms of the cover, you can ask the kids to just say, what do you see? What do you notice? And so I'm sure that they are all going to know what they're seeing on this cover because they are such good Christian kids, and they're going to say, it's Jesus and he is feeding the multitudes. So he is multiplying the loaves of bread and the fish, and he's making sure there's enough for everyone to eat. So yes, that's why we're seeing this for multiplication. So it's a great way to show multiplication this week, and I would just let them talk. So you could just say, what do you see? And they're probably going to start talking. I had kids who were counting how many loaves they could see in here. And maybe you could say, and what would be multiples of that? Okay, if you see 7, what are our multiples on that? And they can start singing their skip counting songs and just being excited about multiplication, because that's what we always want, right? Okay, and then there's the Chesterton quote, and so I have in the contribution, it just kind of says, Chesterton's quote reminds us that God's provision is replicated day after day because he loves us so. And then the reflection is from Genesis, and so you can read it or you can let one of the kids read it because they might remember. Some of them have memorized this from earlier years in Genesis. I think they're actually doing Genesis. Oh, maybe they did it last year. I don't remember. Haven't been in foundations for a while, but you can have them read it or you can say it. They might be able to sing it because they remember it, but it's about, since the beginning, God has just multiplied all of the creatures on earth and just created more and more. And you can ask them any other thoughts about the cover and the artwork, but that should be no more than 10 minutes. And now we're moving into the math. So the next thing I have them do is say, where are we at? And so they'll look up their compass page. They'll look down on either complex or monomials and point out that we are on week 5 multiplication. We're still in one dimension. So we're still just dealing with one plane that's moving out in one direction. Okay. So the next thing is to look at your invention page. So the I2 page, one that kind of looks like this. I don't want to stay on it too long because I'm not supposed to be showing you guys the stuff from Math Map. So you can look at on your page, but you know which page I'm talking about. Okay, so 5 common topics. So the first thing that you could consider talking about is comparing the intervals. And there's a lot of intervals on this whole bottom part. Let's just look at 2 different ones because I want to compare the union and the intersection. And so if you wanted to use this as like the one thing you talk about in class, you can show these to the kids so that they can understand it a little better. I'm looking at this very first box, and so I'm going to rewrite it. So we have negative infinity to A and union with infinity and, oh wait, no, we're still doing negative, right? Yep, negative infinity and B. Okay, so if I'm drawing this on my line, and I find it helps to redraw it on the board because it's hard to make sure that they're all looking at the same thing on their page. So I just usually rewrite it on the board if I'm going to show an example of something. So this first interval, we have A is our point, and we have a parentheses here, so we know this is an open interval. So we are not including the point A, we're only going up to the A, and then our arrow is going to head out into the negative infinity direction. So this goes out here, and then let me switch my colors. Over here we have B, also an open interval. So we have a parentheses, not a bracket there. So we have our open interval, and B is also heading to negative infinity. So it's heading out this way as well. And because it's union, we are looking at everything that we have combined. So we are looking all the way here from, not including B, but we are looking all the way at B and then all the way past, because it's the union or the combination of both of those things. So our final thing is negative infinity to B, or anything less than B. So X is less than B, because it doesn't include B, so I don't have an equals then. It's just less than B, and then everything in the negative direction. So that was an example of union. Now let's look at the example of intersection, which they show 2 more below. Gives you the intersection example. So if I erase some of this, and I like re-showing the simplest example I can find on the page, because I find for the 7th graders that might be all I can get them to see from this, and they're going to be re-seeing these invention pages for the next 6 years, and they'll pick up more and more on them as they're going further along in their math. So find the simplest thing that they can focus on so they can just understand what the concept is, and then they're going to build from this on the future years. They don't need to understand everything on that page. I just try to find like what's the simplest thing I can pinpoint on this page. So if I look at this example again, and so I'm still going to keep it like this. Actually here, let me switch it up a little bit. I'm going to make this a square bracket. So here's a bracket. That means I have a closed interval. So in this case, my A is going to include my A. Actually, I don't know if they do that. Yeah, they do that on the example. So there we go. So it's a closed interval because it includes the A, square bracket instead of the parentheses, heading out to negative infinity. And then over here, I still have my B. I'm not including it. It's a parentheses. I'm still heading to negative infinity. But in the case of intersection, so I don't have union, this time I have intersection, which is kind of like an upside down U. I'm only including where they overlap, where it's present in both intervals. And so the only thing that actually overlaps here is the point where this B line heading to negative infinity meets up at the A and then heads to negative infinity. So the only actual intersection where they overlap is the negative infinity and the A, including the A. So that's an example of union versus intersection and kind of reminding them on the closed and open intervals. So if you wanted to choose that as one of the 5 common topics, that would be comparison. So that's the example Dr. Gilpin showed for comparison. And as a reminder, you're not getting through all these 5 common topics because there's just not time, but you could pick one maybe that seems of interest to the kids or that makes more sense to you, and so you want to kind of teach it and show it to them. The next thing to talk about, 5 common topics, definition. And so she says to define scalar. And so for scalar, we're talking about something that's going to scale or multiply something by whatever the amount is. So in 7x, my scalar is my 7, and I'm increasing my x 7 times. So I scale it up or multiply it by 7 times. So that's just what a scalar is. Most of the time, it's kind of like our coefficient in the front of this variable. So we're just scaling that up. Scalars are different than vectors. So the scalar shows us that we are continuing. If it's positive, we're continuing in the positive direction. If my scalar, if I made this a -7, it means I'm reversing the direction of whatever I was going in. And in the case of vectors, so if I had like a vector V, and I have my positive vector V, and it's going like in this direction, but I have 2. 2 is a positive number here. So this scalar is saying, well, I'm doing 2 of these, and I'm continuing in the same direction. But if I made this a negative, the negative means my scalar is reversing the direction, and so it's moving negative. It moves to the negative. So vector, as a reminder, magnitude and direction. So the scalar just has a magnitude or a size, but a vector tells us that we have a direction as well. Okay, we've said that a few times now, so hopefully the kids are starting to kind of pick that up. Circumstance for the 5 common topics. When are the circumstances preserved? So this is the idea that a positive scalar means you're continuing the same direction. Negative scalar means you're reversing the direction of whatever you had. The scalar itself is not the direction. The vector is telling us the direction, and so the scalar value just reverses whatever direction that vector was heading in. Relationship is the next of the 5 common topics. So the relationship of functions. So last week we talked about functions and we did the little Minecraft example. So we have our domain with our inputs, and we have our range over here with our outputs. And so if we had an f of x, last week we were doing like x plus 2. So in this case, we could do x times 2. Try to make my little times guy smaller than my other x. So, if I have 2 over here, I'm doing 2 times 2, and my range becomes 4. So the inverse function, and you just have, it's the f of x, but you have that little -1 here for the exponent to show it's an inverse, would be the opposite of what x times 2 is. And what's the inverse of that? It would be the number divided by 2. So it's the division of it. So if you had 4 over here, you work in reverse, then you get back over to 2 in this direction with the inverse. So just comparing the functions with the inverse, and they show that in the red box is the function and the inverse is in the green. So just kind of pointing that out so the kids understand that. And then the 5th of the 5 common topics is the idea of authority. And so this, Dr. Gilpin gave the example of commutative property, and that is one of the laws of multiplication. So last week we talked about laws of addition. This week they'll talk about different laws of multiplication. Commutative property is the idea that A times B is the same as B times A. So 2 times 3 is the same as 3 times 2. And we saw that with addition last week. So commutative property is the authority. So what's the authority on the commutative property? Is just that it's the rule or the law that tells us that A times B is the same as B times A. And there's other multiplicative laws that they're going to look at this week. And they're all on chart 1, and they'll have it in their student problems where they have to figure out which laws they're seeing in the booklets. Okay, so that was a lot for that invention page. And like I said, maybe just pick out like 1 or 2 of those things to talk about with the kids. The next page is the I3, the memoria and arrangement, lots of things with factors and fractions on here. And in my original notes, I'm actually changing my original notes from last year on the lesson plan because I talked about talking about least common denominator, least common multiple, and then memorizing those, and then polynomial factors and a couple other things like that. But the kids don't actually do any of that. Well, they do the least common multiples, but they don't do the some of that other stuff in their problems this week. So I think the bigger thing to focus on, if you really want to help your kids be able to work on Math Map at home for this week, is to help them see in here 2 main things. And if you have monomial kids, there's 3 things you might want to talk about. And so the first is greatest common factor. Greatest common factor. And so this is the idea, if it's been a while since you've done some of these fractions, and it had been for me, of what are the factors going into it, and if you're looking and comparing a few different numbers, what's the largest number that they all have in common that's a factor of those numbers. So for example, 2, the numbers that are factors for 2, you have 1 times 2, and that's it. You don't have any other factors. For the number 4, you would have 1 times 4. You would also have 2 times 2. So the factors for 4 are 1, 4, and 2. If I wanted to compare and say what's the greatest common factor for 2 and 4, well, the greatest number that they both have in common that's a factor is 2. So your greatest common factor would be 2. Sometimes the greatest common factor is going to be 1 because they just don't have anything else in common, and that's okay. It can be 1 as the greatest common factor. And then the other thing that they'll have to do in their student problems a lot of is least common multiple. And so that's when you look at the multiples, or multiplying out your numbers and finding the one that they have in common that's the least or the lowest number. So in the case of 2 and 4, okay, multiples of 2, they've got this down because they know they're skip counting. 2, 4, 6, 8, 10, 12. Okay, so I don't even have to go that far. Okay, and then for 4, 4, 8, 12, 16, 20. Okay, so they can go on, but they don't have to go that far because the lowest common multiple for both cases is 4. So your least common multiple of 2 and 4 is going to be 4. So that's what they'll have to do if they are a complex student on their student pages. Greatest common factor, least common multiple. So if you're going to pick, and they actually don't even, they talk about least common multiple on this invention page or at memorial page, but they don't even show greatest common factor, but they're going to have it in their problem. So I think the nice thing to do, just refresh them on what that is and what it looks like. And then if you have monomial students, you also have prime factorization that they need to know. And so just a reminder on prime factorization. So if you have a number and you're trying to break it down to its prime values, all the base primes, the base numbers that are down to the level of prime. So for 24, you could have 2 times 12 are both factors into 24. 2 is a prime number, so that's not going to break down any smaller. 12 though is still a composite number, so that keeps breaking down. You can have 3 and 4, so 3 times 4 becomes 12. 3 is a prime number, so I'm done here, but 4, still a composite number. I have to keep breaking it down, and so that breaks down to 2 and 2. Those are both prime numbers, and now I'm done. Everything's down to the level of being a prime number. So my final primes are 2 times 3 times 2 times 2. And if I multiply those, 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24, and 24 was what I had up here. So when you get down to those prime values, they should multiply out and get you back to your original value. And the other way to write this is to say this is the same as saying 3 times, and I have 2 times 2 times 2, which is the same as 2 with an index of 3 or cubed, 2 cubed. And it's nice to write it like this because we can use these values as we're comparing a lot of different numbers and we want to find out what denominator they would all have in common. Like if we need to simplify or we're doing addition and so we need the denominators to match, we can look at what their highest prime power is and we can multiply those together and it'll tell us a common denominator that's going to work for every other number. So the kids don't really have to worry about that yet. You don't have to worry about it too much, but it's important to look at it this way because they will use that later on in math. Okay, but for now, all they have to do, actually they do this a little bit differently on the, let me see how if I can write it out how they like to write it out. Okay, so they are doing it in their booklets like this. And so they will put 24 and they would say, okay, divide that by 2. And I think they write it like this. Oh, they write it over here. Divided by 2 will get you to 12. 2 divided by 2 will get you to 6. 6 divided by 2 will get you to 3. And then 3 can only be divided to 1. So you can't go any further. So your actual, or 3, sorry, so then 3 is divided by 3 to get to 1. There we go. Okay, so that's doing it correctly. And so then you can see, laying it out this way, you're still getting to 2, 2, 2, and 3. 2, 2, 2, and 3. So you still got to those prime values. It's just a different way of writing it. My brain works better when I make it like a tree. But all of their work problems for the monomial kids are going to work in this fashion. So I don't know, maybe it makes sense to just show them that way from the beginning, or you can show them this way to see if it makes more sense, and then show this way is another way to write it as they're working through their problems. But this is something that the monomial kids will be doing in their student pages. Okay. The other thing that I thought was important to note is when they're looking on their pages and they see something where a numerator and denominator match, so a number is being divided by itself, that breaks down and simplifies to just be 1. And so anytime a number is just going to turn into 1, MathMap puts this little green box around it, which helps the student see right away that that number is going to become 1. And so it makes it easier for them to see that. And then when we're going to do things where we're multiplying and we're multiplying by 1, but we have it written as a fraction where it's a number over itself, we're not changing anything because we're technically just multiplying by 1, but you might be using that to multiply out certain numerator guys and canceling out other things. And so it just helps the kids to understand it doesn't really change anything because this is still just totaling 1. All right. So that's what I would focus on there. And then in terms of the charts match up pretty nicely with the way the pages are laid out this week. Dr. Gilpin mentioned that probably the key idea for the week, or one of the key concepts, is multiplication notation. And so this I consider just kind of a reminder of multiplication for the kids. So just kind of give them a little reminder that if I have 5 times 4, I can write it like this. I can also write it 5 times 4, and I can also write it 5 times 4. So these 3 symbols, whether it's this multiplication sign, the little dot, or the fact that the parentheses are right there and the 2 numbers are next to each other, all of those things are multiplying. They all mean the same thing. So help remind them of that, because that's a good thing to make sure that they see that and they know what that is for some of the kids. And then also distributive property is a good thing to remind them on. And that's the concept. I have a scalar like my 2, and then maybe over here I have 4 plus I. So I'm throwing a little complex number in here. Okay, so when we are talking about a scalar multiplying this whole expression, it's scaling it up or multiplying that whole thing. So you have to make sure you're distributing to all the terms within the expression. So this would be 2 times 4, which gets us to 8. This would also be 2 times I. So we're going to bring down our plus. 2 times I is 2I. So that case, you have to just make sure they're distributing it. And I found in my class last year, maybe about half of my kids were starting to work with math where they were distributing, and they kind of see that quickly. And maybe half of my kids were not quite doing that, or they haven't been doing a lot of that yet. So it's a good thing to just kind of remind them, because as they're going through and doing their math, they're going to have problems like this. And they need to make sure they understand that they have to distribute to all the terms in the expression. Okay. I mentioned a little bit about FOIL on this page. None of my kids were ready to start talking about FOIL. That's the concept where you have 2 binomial terms, and then you're having to do the first items, the outside, the inner, and the last. Nobody was at that level yet, so I probably actually will take that out of the lesson plan, because I don't think the 7th graders are ready for that. Maybe some of the 8th graders would be. Okay, next is the rhetoric stage. So any aha moments, if they want to bring up something from last week that they learned or they saw or they were surprised about, or if I had any issues or problems or wanted to share something, that's the time to do it. My class usually didn't have any stuff from last week they wanted to talk about. So then we jump right into doing the actual problems. And so this week, let me see what they look like. Yeah, so they all have tops to the 4 parts. And so I would try to write what I would do, and people have asked me about this. I tell the kids, I put them in their groups of 2, and then sometimes I'd have one group of 3, or I might have a kid who's solo if they felt comfortable with that. And so then, like where it shows the scalar and the hops on the imaginary line, so this is like the first problem, and you're having this, and what does it do? Okay. And the first one's done for them. And so then I would put, if the first one's done for them, they don't need to do anything. But I can write the next one up here for them. And so then when they're done working in their groups for like 5 to 10 minutes, usually closer to 10 minutes, then I say, when you're ready, come on up and draw this up on the board. And so I would have different color markers, and they would come up to the board, and I actually don't know what this one is. Oh, it's -3. Okay, so this one, they're going to be showing how it goes down. And they would fill in with their other color what the answers are for those problems. And we would do that. We would have the board, and I'd lay out the first 4 pages up on the board, and then they would fill it out, and then the other students could all see what the answers are. And I'd kind of briefly go through it. I tried one week to let the kids try to explain everything, but they're a little bit slower to it. So if that works for you and you don't have a lot of kids in your class, you might be able to let them explain to each other, because there's nothing better than them being able to teach it and explain it. but sometimes I felt we didn't have enough time to kind of go through that. So I would point out, great job, where they got everything right. And I'd say, this is what Greta had done. And I would show that example of this is what she was doing and what she showed. And so I might talk about it just because it could go a little faster. Remind them about their week 29, Seeing the Unseen, and then run through the catechism real quick. At this point, it's what are the solutions for? To check my work and work backwards. So you're just quick asking the questions and they can quick give you the answers, because they should kind of be knowing this stuff by now. So there you go, short and sweet. That's what week 5 looks like. And don't forget, I have that math program now, Math Explorers, and I go through in far more detail and a lot slower with more examples on what is prime factorization, what are prime numbers. Let's sing a song to remember prime numbers. Let's look through greatest common factor. Let's look through a few examples of that. So I go through videos about 15 minutes long, 10 to 15 minutes long on each of those topics for each day. So there's 4 videos for the week that they're working on at home. And then they can go through and start to tackle their problems because they have a little bit better understanding of that base math. So that's the Math Explorers program. If you have some students in your class who are needing some extra help, or the parents feel like they can't be the ones teaching this, they're working part-time, they have a lot of other kids, it's just something that they can't be like part-time dedicated to understanding all the math and learning the math to teach their kids the math, that's where it comes in handy. So thanks for spreading the word for those of you directors that are using it, and maybe using it with your own kids or sharing it with other kids in your class. I think it's helping some families. So thanks so much, you guys. See you next week.